You know, there is this incredibly mundane moment that you experience almost every single day.
Oh, yeah. Constantly.
Right. Like you are sitting on your couch, you have got an item sitting in your online shopping cart, or maybe you are finally signing up for that new streaming service everyone is talking about.
The one you've been putting off for months.
Exactly. So
Yeah.
you type in your credit card details, you hit submit or pay, and then you just wait.
Just for a second.
Yeah, it is usually just a fraction of a second. A little loading wheel spins on your screen. And in that tiny, fraction of a second, you probably assume the website is just calling your bank to check if you have enough money in your account.
Right, like a simple digital handshake.
But the reality is, during that literal blink of an eye, an invisible, incredibly high stakes war is being waged over your digital identity.
It is entirely invisible to the user by design.
Yeah.
I mean, the sheer scale, the computational complexity of what happens in that single millisecond would probably shock most people.
Oh, I bet.
We are talking about analyzing hundreds of variables before your finger is even, like, fully lifted off the mouse button.
And that invisible digital battlefield is exactly what we are looking at today. Welcome to your personalized deep dive. We are pulling back the curtain to show you the actual machinery that runs our online lives.
It's a really fascinating space.
It really is. And we've got a great stack of sources today. We are looking at internal documentation, detailed architectural overviews, and real-world case studies from a platform called SEON.
Right, SEON.
Yeah, and they operate what they call an AI command center for fraud prevention, and AML, which stands for anti-money laundering compliance.
Which is a huge deal in the financial sector. And this source material, it serves as a really comprehensive look at the modern state of digital security. I mean, the industry has moved so far beyond the old model of just, checking if a password matches a username.
Oh, totally.
We have fully entered the realm of behavioral biometrics, complex network mapping, and real-time artificial intelligence.
So our mission today is to help you understand exactly how this machinery operates behind the scenes. We want to show you how businesses are using these tools to protect themselves and, by extension, protect you, without you ever even noticing it is happening.
Because if you noticed it, they wouldn't be doing their jobs right.
Exactly. Okay, let's unpack this. Because to really understand how modern criminals are caught, we have to start at the very beginning. The defenses do not start when you hit buy. They start the moment you simply arrive on a website.
Yeah, the perimeter has expanded massively long before you even attempt a transaction or create an account. The platform is already gathering telemetry.
And it starts with something you see literally constantly, the cookie consent form.
Oh, everyone's favorite pop-up.
Right. We all just blindly click accept all to get that annoying banner off our screen so we can read an article or whatever. But the source material gives us a literal breakdown of what happens when you do that. It lists an entire army of trackers.
It's wild when you see them all listed out.
It is. You have got categories like necessary functional statistics marketing. And it mentions specific providers operating in the background, like Google, Hotjar, HubSpot, Clearbit.
And if you look closely at the documentation for how those specific trackers operate, they are not just passively counting page views.
What are they doing then?
They are logging your screen resolution. They are checking if your browser supports certain, like, obscure HTML5 functions. They are tracking your navigation behavior and assigning you unique session IDs.
Wow.
Some are even using invisible pixel trackers to see how you move between completely different, seemingly unrelated websites.
But the sources highlight one specific phrase that really caught my eye here. Amidst all this tracking for marketing and targeted ads, there is something called device fingerprinting.
Right?
And the documents note it is used specifically for information security and fraud prevention. I always thought a device was just tracked by its IP address or, a cookie.
Well, a browser cookie can be cleared in 2 seconds. And an IP address, I mean, that can be masked using a virtual private network, a VPN, instantly.
Right. Everyone has a VPN these days.
Exactly. Those are trivial hurdles for a modern fraudster. But a device fingerprint looks at the unique, deep-level configuration of the hardware and software you are using. It looks at the specific minor version of your operating system.
Oh, wow.
It looks at the exact combination of custom fonts installed on your machine. It checks your graphic card's rendering behavior by forcing it to draw an invisible shape and measuring the exact pixel variations.
That sounds like sci-fi.
It does. It even checks your battery level and your localized time zone settings.
Wait, hold on. It checks your battery level. Why on earth would a fraud prevention tool care if my laptop is at 20% or 80%?
Okay, think about it from the perspective of an organized fraud ring. They are not sitting there with a single iPhone typing in stolen credit cards one by one.
Right, they'd be too slow.
Exactly. They are running massive server farms, using emulators to simulate tens of thousands of different mobile phones to launch automated attacks. But a server farm is plugged directly into a wall.
Oh, it doesn't have a draining battery.
Precisely. So if the system detects a device claiming to be an iPhone 14, but its battery level is statically locked at 100% for 3 straight hours while it rapidly attempts thousands of logins.
The fingerprint exposes the lie.
Exactly. When you combine all these tiny, seemingly innocuous details, it creates a unique identifier, a fingerprint, that is incredibly difficult, mathematically speaking, for a fraudster to successfully fake at scale.
And this leads directly into what SEON calls their pre-onboarding defense. The documentation says that the very moment a user types a name, an email, or a phone number into a seemingly simple form, SEON is already analyzing that IP address, their digital footprint, and these device signals to surface risk.
All of the background.
Right. And this all happens before the user even gets to the formal KYC, the Know Your Customer check, where you typically have to upload a photo of your driver's license. It's like a bouncer at a heavily guarded nightclub.
That's a great way to put it.
Yeah, like it's a bouncer who doesn't just check your ID at the door, but somehow knows if your shoes have mud from a specific neighborhood or if you arrived in a stolen car, all before you even reach the front of the line.
What's fascinating here is SEON's approach to the data itself. A lot of legacy platforms in this space act essentially as data resellers.
What do you mean by that?
Well, they purchase massive lists of known bad IP addresses or compromised email domains, and they just cross-reference incoming traffic against those static lists.
Which, sounds logical, but I imagine that data gets stale incredibly fast. If I am a hacker and my IP address ends up on a blacklist, I'm just going to spoof a new one 5 minutes later.
Precisely the issue. By the time a bad IP makes it onto a purchase blacklist, the fraudster has already moved on. SEON, according to these sources, does not rely on those stale third-party lists.
So what do they use?
Instead, they rely on a foundation of over 900 first-party data signals. They are analyzing the live, immediate, physical reality of your connection.
Over 900 signals. Just from someone typing an email address and clicking around a web page?
Yeah, they are actively querying the surrounding digital ecosystem in real time. They are checking things like, is this IP address coming from a residential internet provider? Or does it originate from a known commercial data center typically used to route VPN traffic?
Wow, okay. Right.
Does this email address have active profiles on social media networks like LinkedIn or Pinterest that match the rough age and demographic the user is claiming to be on the form? Checking over 900 live signals gives them a level of coverage and precision that looking at yesterday's blocked list simply cannot match.
Okay, but gathering 900 data points on every single user interaction creates a massive logistical problem. Think about a major online retailer or a global payment processor. They are dealing with millions of users every single day.
Millions of transactions, yeah.
So how does a company actually process that tidal wave of data to make a split-second decision? And more importantly, how do they do it without accidentally slamming the door on innocent customers?
Well, that tension is the central paradox of the fraud prevention industry. It's known as the false decline problem. Security is easy if you just block everyone.
Right, but businesses need to make money.
Exactly.
Because every false decline is a lost customer. If I try to buy a pair of running shoes and the system wrongly blocks my credit card, I am not going to call my bank, wait on hold, and try again.
No one has time for that.
I am going to open a new tab, go to a competitor's website, buy the shoes there, and probably tell my friends your website is broken.
The documentation is very blunt about this. Every false decline is a customer you just handed to your competitor. So to solve this, SEON centralizes all this incoming data into an AI command center.
And how does that work in practice?
They provide businesses with an intuitive drag-and-drop workflow builder. This allows a company to seamlessly orchestrate different checks. They can combine the initial footprint checks we discussed with identity verification, liveness detection.
Liveness detection, that's when you have to take a quick selfie to prove you are a breathing human, right?
Yes, exactly. So they combine that and even heavy-duty anti-money laundering screening. They build an automated journey. The entire goal is to approve the real legitimate customers instantly, while automatically introducing friction only for the suspicious ones. And the AI tools can actually cut manual review time by up to 50%.
Okay, so here's where it gets really interesting and honestly a little concerning.
Ooh, how so?
Well, if a business is relying this heavily on an AI command center to process 900 signals in a millisecond, doesn't that just create a massive black box?
Ah, the black box problem. That has haunted machine learning for years. Early AI models were notoriously opaque. They would issue a ruling, and no human could reverse engineer why.
Right, and practically speaking, think about the customer experience.
Ah.
If a legitimate customer's payment is declined, they are going to call customer service, and they're probably going to be pretty angry.
Yeah, definitely.
So if the system is a black box, isn't the customer service rep basically forced to just shrug their shoulders and say, well, sorry, the machine said no?
That's a nightmare for a
Yeah.
business.
Even if you tell me the AI has something called score explainability, handing a stressed out customer service rep a spreadsheet of 900 raw data points while a customer is screaming on the phone is just as useless as a black box. How does a human actually parse that in real time?
That is an excellent point, and the engineers behind this clearly recognize that raw data is not the same as actionable intelligence. The SEON documentation highlights features specifically designed to bridge that gap between the machine's logic and the human operator's reality.
Okay, so what's their solution?
When the AI generates a risk score, it does not just spit out a number, and it doesn't just dump 900 raw data points. It uses what they call context-rich summaries.
Meaning the AI translates its own math into human language.
Exactly that. The AI provides a plain language explanation of why a transaction was flagged, and it ranks the specific signals by their impact.
Oh, that's clever.
So, the customer service rep doesn't see a wall of code. They see a clear sentence, like, this transaction was flagged with an 85% risk score because the IP address originates in London, but the shipping address for the physical goods is in Tokyo, and the email address used for the purchase was created less than 10 minutes ago.
Wow, so the human reviewer instantly sees the story of the fraud.
And they can explain it logically if an audit is required. Furthermore, the system includes an AML screening agent that actively cross-validates hits to flag likely false positives before the human even sees it.
That saves so much time.
It really does. The AI is not acting as a blind, unthinking judge executing sentences. It is acting as a highly transparent, highly efficient assistant to the human fraud team. The ultimate goal is to make every single decision completely defensible.
Okay, so we have got the front door heavily secured. The onboarding process is tight, the AI is explaining its decisions in plain English, and we are letting the good customers sail through while keeping the obvious fraudsters out.
Right.
But what happens if a fraudster is smart enough to bypass the front door entirely?
Like, how do you mean?
What if they just buy the stolen login details of a perfectly legitimate user on the dark web? The front door defenses wouldn't catch that because the fraudster is using the right keys to get in.
Ah, yeah. That scenario requires a complete shift in defensive architecture. You have to abandon static, point-in-time checks, like the verification that happens only at checkout, and transition to active, continuous monitoring.
Catching the ghosts who are already inside the machine.
Exactly.
The source material outlines SEON's activity monitoring module, which watches accounts post-login specifically to detect account takeovers, commonly referred to as ATOs, in real time. And they do this using a combination of device intelligence and behavioral analysis.
This is where the technology gets incredibly sophisticated. The system is no longer just looking at what you are doing. It is intensely focused on how you are doing it.
Yeah, the sources mention it can actually spot screen sharing, remote access tools, and suspicious navigational patterns. It is like, okay, imagine a bank teller noticing that a regular customer who usually comes in every Tuesday and signs their checks slowly with a blue pen is suddenly writing with their left hand, sweating profusely, or has an earpiece with someone whispering instructions to them.
That is a brilliant way to conceptualize digital behavioral biometrics.
Right. The signature matches the one on file perfectly, but the actual physics of how it was written are entirely wrong.
Yeah, the software analyzes your typing cadence, the specific arc of your mouse movements, your hesitation times before clicking.
It's that granular.
Oh, absolutely. If a user always logs into their account from a Mac in Chicago, and they naturally type at about 60 words per minute, and suddenly that exact same account logs in from a PC in Eastern Europe using a network port known for remote access software, and the mouse movements are unnaturally perfectly straight or highly erratic.
The system notices immediately the digital physics are wrong.
Exactly.
So when the system spots those broken digital physics, What is the immediate reaction?
It triggers what they call a step-up verification. It dynamically introduces friction.
What kind of friction?
Well, instead of just letting the transaction proceed, it might suddenly ask for a one-time passcode sent to the user's phone or require them to re-authenticate with a biometric scan. This protects the legitimate user's account and money without necessarily banning the account outright.
Just in case it actually is the real user who just happens to be traveling and using a weird hotel computer.
Exactly. You don't want to ban them for taking a vacation.
Makes sense. And there's another layer to this post-login monitoring that blew my mind. The documentation calls it network analysis. The sources say the AI visually maps relationships across shared devices, IP addresses, and emails by connection strength.
If we connect this to the bigger picture, network analysis is arguably the most devastating tool against modern cybercrime.
Really? Why is that?
Because fraud is rarely just one lone hacker sitting in a dark basement anymore. It is highly organized, heavily industrialized, corporate-level crime.
Which means if you catch one bad account, you can't just ban it and pat yourself on the back.
Right. You just ban the individual bad account, you are essentially swatting a single mosquito. They will just spin up another account and keep coming. Network analysis allows the AI to eliminate the unseen connections.
Like finding the whole hive.
Yes. It might notice that the subtle device fingerprint used by that one bad account, maybe a specific rare audio card driver combined with a specific time zone mismatch, was also used to log into 50 other seemingly unrelated accounts over the past month. Suddenly, the AI reveals the entire hidden fraud ring without manual searching. You aren't just swatting mosquito anymore. You have found the coordinates to take out the entire nest.
And the system doesn't just rest on those discoveries either. The text highlights a model tuning feature where the AI retrains itself daily on the client's own labeled data to continuously fine-tune its risk scoring. It is learning every single day from its own environment.
It adapts to the specific evolving threat landscape of that individual business. I mean, the type of fraud attacks targeting a mobile video game company are structurally very different from the attacks targeting a major international bank.
Oh, for sure.
The AI learns the unique rhythm of both the legitimate users and the bad actors for that highly specific environment.
Okay, so this technology sounds incredible. It honestly borders on science fiction. But how does this actually translate to the real world? We are talking about business survival, heavy regulatory compliance, and the bottom line. Is this all just theoretical tech utopia, or does it actually work in the trenches?
Oh, it absolutely works in the trenches.
All right.
The sources provide some very concrete numbers on both implementation speed and financial impact. Usually, integrating enterprise-level security software takes months, sometimes stretching into years of agonizing IT deployment.
Sounds like a nightmare.
It is. The industry norm cited in these documents is that only 10% of fraud tools manage to go live in under 2 weeks. But SEON averages just 14 days from the start of implementation to seeing active impact.
14 days. That is an incredibly aggressive timeline for something that integrates so deeply into a company's payment architecture.
It speaks to the modern architecture of the platform, and they are backing this up with serious engineering muscle. They have over 120 dedicated R&D engineers, and they recently raised an $80 million Series C funding round to expand.
Wow, 80 million.
Yeah. And crucially, they're also tackling the massive, incredibly dry but vital headache of AML compliance.
Right, and AML anti-money laundering isn't just about protecting a company's profit margins. It's about keeping the executives out of federal prison. The regulatory burden there is absolutely massive.
It is a staggering operational burden. For a lot of financial institutions, AML compliance involves literal rooms full of analysts staring at manual spreadsheets, trying to manually connect the dots of suspicious money movement.
That sounds miserable.
It's tedious, and banks are legally required to file incredibly detailed, complex reports like SARs, which are Suspicious Activity Reports, STRs, and Form 8300s to government organizations like FinCEN in the U.S. whenever they spot potential money laundering.
Right, and if they mess that up.
The manual process is agonizingly slow, prone to human error, and missing a major laundering ring can result in hundreds of millions of dollars in federal fines. SEON uses AI to autofill these regulatory reports, draft the narrative summaries of the suspicious activity, and securely file them directly to the government watchdogs, all while maintaining a flawless digital audit trail. It replaces a high-stress manual process with instant automation.
We actually have some deep dives into case studies here that show exactly how this plays out across different industries, and the results are pretty wild. Let's look at PayUp first.
Right, the payment processor.
Yeah, they scaled secure payments across over 500 methods and got a 15% reduction in manual review times. They basically achieved system-wide visibility to block fraud across their platform before it spreads.
Which is huge for a payment processor.
Yeah,
And then there's Lottoland.
right. The sources state they achieved a 32x return on investment and a 70% reduction in something called bonus abuse. Now, when we talk about fraud, we usually picture stolen credit cards. But bonus abuse is an entirely different kind of theft, isn't it?
It is a massive drain on e-commerce and gaming. Businesses offer sign-up bonuses, like, get $50 free when you create an account to attract real customers. Organized fraudsters use automated scripts to create thousands of fake synthetic identities just to harvest those $50 bonuses over and over again
Oh, wow.
and drain the marketing budget dry without ever spending a dime of their own money.
But because SEON's network analysis maps those subtle hardware similarities, it realizes those 5,000 new users are actually all coming from the same server farm. It destroys the nest, saving the marketing budget.
Exactly.
And it's not just gaming. Card Market uses it to block fake accounts and bots at scale, screening over 2,000 registrations daily without adding friction for real users. And Bill highlighted their incredibly flexible rule writing.
And then you have a traditional financial institution like DB Bank. The source notes that by implementing this platform, they actually increased their loan approvals by 5%.
So, what does this all mean? We are conditioned to view cybersecurity and fraud prevention as an expensive IT tax that companies are just forced to pay. But looking at these numbers, can security actually be a revenue driver?
The T-Buy Bank and Lottoland case studies prove definitively that modern security is a revenue driver. When a business is forced to use outdated, static security systems, they operate entirely out of fear. Because they can't accurately tell the good users from the bad, they make their rules incredibly strict to avoid catastrophic losses.
Which brings us back to that false decline problem we discussed earlier.
Exactly. They end up turning away perfectly good customers and rejecting perfectly profitable loans simply because their technology lacks the precision to be confident.
They're forced to cast a net that is way too wide.
But when you deploy a system that analyzes 900 signals in a single millisecond, with an AI that explains its context and maps the hidden networks of devices, you gain extreme confidence. TB Bank grew their loan approvals by 5% because they could finally confidently identify the legitimate users. They stopped having to treat innocent people like potential criminals.
And for Lottoland, eliminating that massive wave of bonus abuse meant their marketing dollars were actually going to real humans who might become loyal, long-term customers, driving that incredible 32x return on investment.
Precision security doesn't just stop financial bleeding, it safely enables aggressive growth.
That is a total paradigm shift for how we think about the internet. It is not about building a thicker, taller wall around the business. It's about building a much smarter door, one that seamlessly swings wide open for the people you want and locks instantly like a vault for the ones you don't.
It fundamentally changes the economics of operating online.
So, to wrap up our journey today, the next time you are sitting on your couch and you breezily check out of an online shopping cart, or you sign up for a new app, and you see that little loading wheel spin for just a fraction of a second, take a moment to appreciate what is actually happening.
There's a lot going on in that millisecond.
An entire AI command center is quietly waking up. It is interrogating your IP address, analyzing your digital footprint, mapping the microscopic details of your device's fingerprint, and actively measuring the exact physical speed at which you typed your own name. It is processing hundreds of complex signals in mere milliseconds, fighting off automated botnets and highly organized international fraud rings, all to keep the digital ecosystem safe so you can just get back to your day.
It is a remarkable, deeply complex, invisible infrastructure. And, thinking about that model tuning feature we discussed earlier, the fact that the AI is continuously retraining itself every single day, learning from human behavior to spot the absolute slightest mechanical anomaly.
Yeah.
It raises a rather profound question. If artificial intelligence is learning every single day from our behavior to spot the slightest microscopic mechanical anomaly, at what point in the future will human behavior have to fundamentally change just to prove to the machine that we are in fact human?
Oh, wow. That is a heavy, almost sci-fi thought to leave off on. Are we all going to have to start purposefully making typos and moving our mouse erratically just to prove to the algorithm that we aren't highly efficient bots? I love that concept. Thank you so much for joining us on this deep dive. It has been an absolutely fascinating look into the invisible, high-stakes world of digital trust. Until next time, keep questioning the world around you and stay insanely curious.